In November 2018, a team from Stellenbosch University, the University of Edinburgh and the Breede Valley Fire Department conducted the world's largest informal settlement fire experiment. 20 full-scale homes were set up, instrumented and burned down to try and understand spread between homes in informal settlements. Only 5 minutes after ignition, all 20 homes were fully involved, showing the rapid rate of fire spread between such dwellings. This video gives an overview of the experiment conducted, showing footage from an overhead drone and cameras stationed on the side. Now, the many team members from the two universities and the Breede Valley Fire Department are gratefully acknowledged for the many long hours that have been put into this project. Here you'll see a plan view of the experiment. The fire was lit on the left-hand side, so 4 dwellings in a row ignited, and then the fire was allowed to spread from left to right. This was to simulate a large fire, a fire line in a large, fully developed settlement that's now tracking through. We had 6 dwellings which were timber-clad, so timber planks on the outside, and then the remaining 14 dwellings had corrugated steel sheeting on the outside. The distance between dwellings was between 1.2 and 2.2 meters from left to right, and then 1 meter between each row from top to bottom. Here you can see some pictures during the experiment showing the steel-clad dwellings, some of the boards used to prevent wind from tunneling through. Here on the left-hand side you can see a timber dwelling with the timber planks, and then also some of the equipment that was placed around the experiment to record temperatures, heat fluxes, and other data recorded. Here you'll see timber cribs set up on the left at about 25 kilograms per square meter, which was our fuel load, and then lining, cardboard lining on the sides to simulate the many combustible items that people have in their dwellings, such as drapes and curtains and floor linings and the likes. And then we also on the right hand side had some barriers to prevent wind from tunneling too quickly through. Now here you'll see the drone footage of the experiment. Once the fire was ignited, at the bottom 4 dwellings is allowed to then move through, with the wind pushing it roughly from bottom to top of the screen or bottom left to top right, and the wind speed was around 15 to 25 kilometers an hour. The fire had reached the second line of dwellings roughly 2 minutes into the experiment, and then continued to spread from there through to the rest of the settlement into the 3rd line, 4th line and 5th line of dwellings. And the large flames emerged from the doors and windows that were open, and then flame impingement and high radiation onto adjacent dwellings caused them to catch fire. Now, at about 5 minutes, the final row of dwellings had ignited, showing the very high rate of fire spread between such dwellings. The imagery you've been watching has been speeded up at about 6 times the normal rate. Now, for the remainder of the experiment, it's about 10 times the normal speed, just so you can see the burnout as the experiment gradually dies down. Already after 6 minutes you can see many of the dwellings had collapsed, especially the timber dwellings, and then after that more and more dwellings collapsed as time went by. At some of the dwellings you can see the timber cribs burning, and then as we get towards the end of the experiment at 20 minutes, one thing you must remember is that by the time a fire has been found, reported to the correct number, and the fire brigade has been able to drive from where they are to wherever the fire is, it may take 10 to 20 minutes. So often they will arrive to find a totally decimated settlement with somewhere between 10, 20, 50, 100 homes fully involved in fire, depending on how far they have to go and how long it takes the call to come through. Here you'll see a side view of the experiment being conducted, all 4 dwellings on the left-hand side ignited, and then the fire moving from left to right. You'll see the many meter high flames emerging from the different dwellings, and many homes collapsing during the experiment. In this experiment, the density of homes was not necessarily unusual. In many dense settlements, you'll find homes right on top of each other, sometimes even double-story, and then simply thin aisles between blocks of dwellings. So in such situations, the fire would spread faster. Also, especially if you had gas bottles, paraffin stoves, highly flammable contents in people's homes, those would also speed up the rate of spread. However, we didn't have doors and windows in the dwellings, so that would have slightly increased the spread rate in the experiment versus real life. In this final video, you can see a front view of the 4 homes where the fire was started, and then the fire was allowed to move away from us. And you can just see how intense it was. Even a firefighter in full PPE wouldn't survive in the midst of that blaze. Now, this work is being conducted to try and understand how fire spreads between dwellings, the mechanisms of fire spread, so that we can better evaluate what will and won't work in these sorts of disasters. So what interventions can be used and what sorts of interventions can't be used. And hopefully with time, this sort of work and much other work can inform good policy and good practice and inform what regulations and what procedures should go into specifying interventions to be used, and also layouts for settlements. But overall, this is moving in the right direction to provide a solid scientific foundation for understanding the conditions and the fires that affect around 1 billion people around the world.